This is a quick demonstration to show you the three ways of performing inter-VLAN communication. I've got the traditional inter-VLAN routing where we have to have one switch link that connects the switch to the router, one per VLAN. Then we've got router on a stick where we have one router and then the switch is just connected to that router using one link. And then we have multi-layer switching. In this method, no real router is involved. We have a switch that is capable of doing layer 3 activities. So we'll start off on the traditional inter-VLAN routing here, taking just a quick look at the configuration here. This is what's on the switch. I have, for Fast Ethernet 01 and 02, I have set them up not as trunk interfaces but as access ports. And notice that I've assigned them to VLAN 50. This PC is on VLAN 50. This other one here is going to be on VLAN 60. So VLAN 50 traffic is going to come up to the router, get routed if it has to go down to VLAN 60 and come back down here. So that's what Fast Ethernet 01 and 02 are about. 05 and 06 are similar. 5 connects off to that PC on VLAN 50, and then 6 connects to this PC on VLAN 60. Otherwise, there really is no other configuration on the switch itself. I don't even have a whole lot for the VLAN information, didn't even bother to name my VLANs here. But you can see that VLAN 50 has been assigned to port 1 and port 5, 60 on port 2 and port 6. So that's what's on the switch. As far as what's on the router, routing configuration is also pretty sparse. We've got the two interfaces coming into the router. Fast Ethernet 00 is in the 50 VLAN, or has a 50 subnet IP address, and then 01 is in the 60. Notice that there is really not a whole lot else that's going on here. If I show the routing table here, you can see that the network of 50 is directly connected out Fast Ethernet 0. The network at .60 is connected off Fast Ethernet 01. So all that means then is that when these PCs, say the computer on VLAN 50 wants to talk to the one on 60, it's going to realize that the destination IP address is a different subnet. So what it's going to do is forward it off to the default gateway. Well, that's your router. The switch just forwards the traffic up to the router. Router gets it, takes a look at the routing table and says, hey, destination IP address of .60 something, so I need to send that out Fast Ethernet 01. It comes down to the switch then forwards it on. That's the traditional way of doing things, and it works great. Very simple setup. The problem is this is a 2 VLAN example. Let's make that 20 VLANs. Let's make that 30 VLANs. And now suddenly this isn't going to be practical because your routers would have to have far too many interfaces. Their switches would lose all of their interfaces for the connections to the routers. So this is not a good way to do things. A better alternative is router on a stick inter-VLAN routing. With this, we have just one connection to the router itself, and that is, in this case for the switch, Fast Ethernet 01 is the port, and it's set up as a trunk port. Okay, I've actually set up the native VLAN and all that kind of stuff here, but Fast Ethernet 5 and 6, this is where the PCs plug in. I've got the PC plugged into 5 is on VLAN 10, PC plugged into 6 is on VLAN 20, and that's really all there is. So you can see that for VLAN 10, only Fast Ethernet 5 is connected in this example. For 20, only Fast Ethernet 6. Whereas if we look back to this other example over here, the switch had two ports plugged into VLAN 50. The one going out to the PC and then the one going up to the router. Same thing for VLAN 60. The one going down to the PC, one going up to the router. Well, in this router on a stick example, only the connection to the PCs belong to the various VLANs. That's all there is. Alright, what's done on the router? The router configuration is a little different here. If we look at the router configuration, there's a little bit more going on. Notice that there is only the one interface connection coming up here, Fast Ethernet 00 up on the router. And notice on Fast Ethernet 00 there is no configuration. That's because we've configured sub-interfaces on this. These sub-interfaces are what make this work. The sub interface is not a real physical interface, but notice that we're starting with fast Ethernet 0/0 for all of these. And then what we're doing is dividing it up or channeling it up. And we do that with a dot. Now you can do this on any router interface just about. We'll get into this in a lot more detail in the WLAN class in Cisco Semester 4. We do this a lot with frame relay. But here's your first introduction to it. So these are just virtual interfaces essentially, and what's commonly done is we will, for each VLAN number, we just do a dot whatever that number is, meaning we have fast Ethernet 0.10 because we have a VLAN 10. We have fast Ethernet 0.20 because we have a VLAN 20, 0.99 because we have a VLAN 99, and so on. So there would be one of these for each of the VLANs that we have. On the router, we also have to specify our encapsulation as being .1Q. This is the IEEE .1Q standard that specifies the VLAN tagging. Okay, got to have that in there, otherwise the router will just try to forward using regular Ethernet communications. Alright, this 10 here at the end is the VLAN number, just as this 20 is the VLAN number, that 99 is the VLAN number. Notice that on the switch I said that we're going to have the trunk port set up and the native VLAN is going to be VLAN 99. Here is how we specify that on the router. So we've got the sub interface, we've got the encapsulation in the VLAN number here. Last thing is an IP address on that interface. Each router interface is going to have an IP address. So here's a 10.1, 20.1, 99.1, just simple IP addresses. So this is the configuration on the router that's necessary to make that work. That's all. There is nothing else. We look at the routing table. Now we've got the 3 connected routes here. Notice they're all out fast Ethernet 0/0, but each separate sub interface is where they're connected. So 0.10 is where the 10 dot subnet is from, 0.20 is the 20 dot subnet, 0.99 is where the 99 subnet is. Alright, so that's what makes this work. If we were to go to the PCs and do a ping here, this is going from the 10.100 computer to the 20.100 computer. First ping request often times out because of our problems in Packet Tracer, but after that the traffic seems to go through just fine. We go over here to the VLAN 20 computer, you can see the same thing. It's able to ping the 10 dot computer with ease. Same thing went on over here in the traditional inter VLAN routing, just to show you that I'm not making it up. The 50 dot computer was pinging the 60 dot computer, success there. And then the 60 pinged the 50, and the success was there as well. So these are the 2 methods that are explained pretty well in the curriculum. Now I'm going to show you one that isn't shown quite so well, and this is a pretty effective way of doing inter VLAN communication, and it's using a layer 3 switch or a multi-layer switch. Notice that there is no extra router involved here. Here is my configuration on this. I have my 2 interfaces that connect off to the PCs, fast Ethernet 5 and 6, VLAN 30 over here, VLAN 40 there. That's just being reflected here in the individual switch port configurations. Where things get a little different is right here. Oops. We've got extra VLAN interfaces here. Got an interface for VLAN 30, interface for VLAN 40. We've seen this before on the other switches. We can only have one interface VLAN up and running at any given time on those other switches. Here with this one, we can have multiples up and running. So interface VLAN 30, give it an IP address, 30.1, VLAN 40, 40.1, VLAN 50, 60, 70, 80. In other words, this would be essentially the default gateway IP address for anyone in VLAN 30. If they want to communicate with anyone outside their VLAN, they send the traffic to the 30.1. That switch at that address will take that traffic and forward it to the appropriate destination, because this switch also has a routing table. It's a multi-layer switch. So it's able to identify where things are. Notice that it sees they're directly connected and doesn't say which interface as far as fast Ethernet and whatnot. it's saying which VLAN interface, which switch virtual interface is connected to it. So the 30.0 network is connected to interface VLAN 30, 40.0 to VLAN 40. That's how this works. And that's absolutely all of the configuration that's necessary. You need to go up to your access ports and assign them to the appropriate VLAN numbers, and then you create these switch virtual interfaces, interface VLAN, whatever, give it an IP address. That's all there is. That's absolutely all there is to it. Now if we go through and ping, we ping the 40.100 computer, everything's going to work just fine there. 40 computer pings the 30 computer, and everything is just fine there. And that's because the switch is able to act as a router. It's a bit more complicated than that as far as how it actually works, but that's what's happening here. This switch is able to actually perform routing, which is a layer 3 task. It's able to do that because it's more than just a layer 2 switch. So these are the 3 methods of configuration for inter-VLAN communication. Stay away from the traditional way of doing things. That's, out of style now. It takes too many interfaces on the router. The router on a stick, that's not a bad way to do things. A little bit tedious configuration, but it's the way you have to do things if all you have is a layer 2 switch to work with. If you happen to have a multi-layer switch, then multi-layer switching is the way to go. If you have one of these layer 3 switches, then life is pretty easy as far as inter-VLAN routing is concerned. Problem is these switches cost quite a bit more than just your regular layer 2 switches. So there you go.